Myself, Madhu S., Assistant Professor of Physics, Government First Grade College, Srinaspur. I would like to discuss on the topic scalar and vector fields. Paper 301, Electricity and Magnetism for BSc Physics 3rd Sem, Bangalore North University, session number 33. Learning objectives from this topic to understand the concept of line integral, surface integral and volume integral, and the importance of Stokes theorem and the Gauss divergence theorem. Course learning outcome from this topic can understand the difference between line integral, surface integral and volume integral. The concept regarding converting from line integral to surface integral and surface integral to volume integral by Stokes theorem and Gauss theorem. From Stokes theorem we can convert line integral to surface integral, whereas from Gauss theorem we can convert surface integral to volume integral. Let us discuss in detail. First, line integral. If the function to be integrated is evaluated along a curve. If the function is integrated and it is evaluated along the curve, then it is called as line integral. The function to be integrated may be either scalar field or vector field. The value of line integral from point P to Q is the sum of value of a field at all points on the curve. Consider a curve PQ drawn between 2 points from P to Q in vector field as shown in figure. Let dl be the element of length. dl be the length of the element along the curve P to Q at point R. Suppose vector A at R making angle theta with the direction of dl, then it can be written as vector A dot dl vector equal to A dl cos theta according to dot product multiplication of two vector is equal to product of two vector cosine angle between them equal to dl A cos theta. If we integrate the function of a curve along all the points from point P to Q, and it can be written as A vector field dot vector dl. Integral of from point P to Q A dot dl also equal to dl A cos theta according to dot product, where integral of P to Q A dot dl is defined as line integral of vector A along the curve PQ. Next, surface integral. If the function to be integrated evaluated along a surface, then it is called a surface integral. Suppose if the function to be integrated is evaluated along a curve, then it is called as line integral. Where the function to be integrated and evaluated along a curve, it is called as surface integral. Let us consider a surface in a vector field bounded by a curve as shown in figure. Let ds is the small element of the surface. This surface element can be represented by area vector ds. N cap represents unit vector drawn outward the surface in the direction of ds. Therefore, ds vector equal to n cap ds. Scalar product is called difference of vector field vector A across the area element ds. Therefore, vector A dot vector ds equal to vector A dot n cap ds. This can also be written as A ds cos theta, again from scalar product or a dot product. Therefore, total flux of a vector field across entire surface area S is given by double integral over vector A dot ds equal to double integral over surface S vector A dot n cap dot ds equal to double integral over S A cos theta ds. Next, volume integral. If the function is integrated and evaluated with respect to volume is called as volume integral. Consider a closed surface in space enclosing volume V. If a vector A be the vector point function at a point small element of volume dV, then integral can be represented triple integral over volume V A dV is called volume integral of vector A over the surface. Volume integrals usually occurs as integrals of scalar quantities. Consider volume V, which is divided into n small volume elements as shown in figure. Each volume element can change from 0 as n tends to infinity. The scalar volume integral is defined as product of each volume element and scalar field f, and sum of their product of all volume elements, that is integral over volume f vector into volume element equal to limits n tends to infinity dv tends to 0 summation I equal to 1 to f of I dot del v of I. Next, we should discuss Stokes theorem. From this theorem, we can convert from line integral to surface integral, or from surface integral to line integral. This theorem states that line integral of vector A around a closed curve is equal to surface integral of the curl of vector A taken over the surface S surrounded by the closed curve. Therefore, line integral over vector field over a closed curve is equal to surface integral double integral over S curl del cross vector A taken over the surface S surrounded by the closed curve. Therefore, from Stokes theorem, we can easily convert from line integral to surface integral, or from surface integral to line integral. Next concept, Gauss divergence theorem. From this theorem, we can convert from surface integral to volume integral of divergence of vector A over volume V enclosed by the surface, or from volume integral to surface integral we can convert. Therefore, this theorem states that the surface integral of the normal component vector taken over the closed surface S is equal to volume integral of divergence of vector A over the volume V enclosed by the surface S. Double integral over surface S vector A dot ds is equal to triple integral over volume V divergence of vector A taken over the volume V enclosed by the surface. From this theorem we can clearly understand we can convert from surface integral to volume integral or vice versa. Session summary. We have been understood the concept of line integral, surface integral, volume integral and its mathematical representation, Stokes theorem, Gauss divergence theorem. Next we shall move on for multiple choice questions from this topic. First question, the Gauss divergence theorem converts option A line to surface integral, option B line to volume integral, option C surface to line integral, option D surface to volume integral. From Gauss theorem, Gauss divergence theorem, which converts from surface integral to volume integral. Gauss divergence theorem uses following operation. Option A gradient, option B curl, option C divergence, option D Laplacian. Gauss divergence theorem uses divergence operation. Answer option C. The following theorem converts line integral to surface integral. Option A Gauss divergence and Stokes theorem only. Option C Green's theorem only, and option D Stokes and Green theorem. Answer is Stokes theorem as well as Green's theorem, which converts line integral to surface integral of a vector field. Stokes theorem converts line integral to surface integral. Option B both A and C. Option C surface to line integral, and option D none of the above. Stokes theorem which converts line to surface integral as well as from surface to line integral. The correct answer is option B. Question number 5. Stokes theorem uses the following operation. Option A gradient, option B divergence, option C curl, and option D Laplacian. Operation. Stokes theorem uses following operation is curl, and option C is the correct answer. References. Thank you.